Hello, welcome to the stream. If you're new here, I'm Jared. You can call me Jardo if you want. My bank printed it on my checks, and everyone thought that was really funny. Like I did 2 or 3 years ago, we're going to be doing the Advent of Code programming puzzles on the stream. What do I have to say about that? Christmas themed programming puzzles, one a day. I am behind. The first two puzzles are already out, and the third one will come out in about an hour and a half. I'm probably just going to do the first one tonight, and then maybe do the next two during the day tomorrow or something. We'll see what the schedule ends up actually being, but that is the plan. I don't know. I don't think I got anything else to say. Let's go do some puzzles here. So I've got a basic template set up here. We're doing this in Ruby. Probably don't need the sidebar. There's not gonna be too much information in there. This code just requires my debugger and then loads the contents of a txt file with a matching file name to this Ruby file for us to use, because that's typically how these puzzles work. I have not yet looked at this year's puzzles, so I am going in completely fresh. I don't know anything about the first day's puzzle. Typically the first days are usually relatively easy in these, and Ruby is an extremely good language for doing these kinds of puzzles. It's typically, these are not puzzles that are, let's say, really performance sensitive. They're sometimes like algorithmically performance sensitive, but as long as your solution lands somewhere in the right, algorithmic complexity, it's usually pretty fine regardless of what language you wrote it in. So not really worried about that. The nice thing is Ruby has tons of really awesome methods on the enumerable, on anything enumerable, that allow us to do really useful things that are often helpful in these kinds of puzzles. So without further ado, let's go look at this year's day 1, 2024, day 1. Day 1, Historian Hysteria. The chief historian is always present for the big Christmas sleigh launch, but nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them as they check the places they think he was most likely to visit. As each location is checked, they will mark it on their list with a star. They figure the chief historian must be in one of the first 50 places they'll look, so in order to save Christmas, you need to help them get 50 stars on their list before Santa takes off on December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. Okay, that's what we're used to. You haven't even left yet, and the group of elvish senior historians has already hit a problem. Their list of locations to check is currently empty. Eventually, someone decides that the best place to check first would be the chief historian's office. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. This seems to be the planning the chief historian was doing before he left. Perhaps these notes could be used to determine which locations to search. Throughout the chief's office, the historically significant locations are listed not by name but by a unique number called the location ID. To make sure they don't miss anything, the historians split into 2 groups, each searching the office and trying to create their own complete list of location IDs. There's just one problem. By holding the 2 lists up side by side, your puzzle input, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. And then it gives us an example here. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far they are apart. Pair up the smallest number in the left list with the smallest number in the right list, then the second smallest left number with the second smallest right number, and so on. Within each pair, figure out how far apart the two numbers are. You'll need to add up all those distances. For example, if you pair up a 3 from the left list with a 7 from the right list, the distance apart is 4. If you pair up a 9 with a 3, the distance apart is 6. In the example list above, the pairs and distances would be as follows. And so it says smallest number in the left is 1, smallest number in the right is 3, the distance between them is 2, and then it goes through. I'm not going to read all of those. Finally, the largest number in the left, so that's expected. To find the total distance between the left list and the right list, add up the distances between all of the pairs you found. In the example above, this is 2 plus 1 plus 0 plus 1 plus 2 plus 5. Total is 11. Your actual left and right lists contain many location IDs. What is the total distance between your lists? Okay, so I'm just going to grab our input. We will put it into this file. And this seems pretty straightforward. This file has only 1,000 lines in it. So I'm actually just going to go straight into my debugger and start playing with it, because I'm just going to write all this code in my debugger. So let's do that. Get this junk off the screen and run this. So input is just going to be a big text thing. If I split that, I get, okay, that's not what I want. I want to split that on new lines. Or can I call dot lines on this? Yes, I can. And then let's strip that off of them, and now I can map this through split, and then I'll get pairs of values. And in fact, I could map that through. So give me a line, and we'll split it, and we'll map this to integers. I think I can do. What did I do wrong there? No. Oh no, just 2i. Why am I calling integer? What language am I writing? No? Oh, I'm just not closing it. And I can't use it in here. Okay, there we go. That's what I wanted. So that's cool. And is this a thing? Yeah. Okay, so there's a transpose method if you have arrays of arrays to do the transformation that I think is exactly what we need here. So this should have 2 elements in it, and the first one will be all of the elements in our like left column, and the end of it. Yeah. So I'm just going to, because that's pretty straightforward. Let's just go column 1, column 2 equals that, and that gets us the start. In fact, we can even map those through sort. And then, I mean, we could just do this in one big chain, honestly. Actually, we might as well just go back to the debugger, because doing that through sort, and then we can retranspose it, find all the distances. Yeah, that's super easy. So we're just going to write all our code in the debugger today. Future puzzles will inevitably be so complicated. I can't do this, but we transpose it back to put them, they're now in order. That looks awesome. We map each one is a pair, so we can, I think we might be able to, how does this work again? I guess we probably want absolute values in here, right? Alrighty, is that the solution? Close our inputs. Correct. All right, so that was relatively easy. And I'll just talk through the solution before we go on to part 2 here. So, editor. This beautiful monster that I just wrote here. I don't even know how to format this in a non-terrible way. Takes all of the lines of the input, removes any extra white space, and then this little chunk here. Here, let's break it up. Goes through each line, converts it into a pair of integers. Then we transpose that array so that we can get it back into columns, sorting each one, then transpose it back to put it back into the pairings that we need, subtract them and take the absolute value, sum all of those, and that gets us our solution. So let's just commit that. I guess we should make sure it actually runs. I didn't mess anything up when I copied it in there. Perfect. So day 1, part 1 complete. And let's go take a look at day 1, part 2. My dog has figured out that it's past time for her to be fed. Hopefully she can wait until the stream's done. Your analysis only confirmed what everyone feared. The two lists of location IDs are indeed very different. Or are they? The historians can't agree on which group made the mistakes or how to read most of the chief's handwriting. But in the commotion, you notice an interesting detail. A lot of the location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. This time, you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate the total similarity score by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. Okay, let me read that again. This time, you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that number appeared in the right list. Here are the lists again. For these examples, here is the process of finding the similarity score. The first number in the left list is 3. It appears in the right list 3 times. 3 times 3 is 9. Do that for all of those. Yes, for these examples, similarity score at the end of this process is 31. Okay. That seems reasonable. So let's take a step back and consider. So, or we just step right back into the debugger again. There we go. What do we want to do? I guess we're iterating over the first list now. So we want to do input lines map. So like most of the stuff that we had before. To get up to the point that we have our separate lists. Typos, cool. transpose. And so we can say list 1, list 2. And that's not beautiful, but it is what I think we want. And let's go hop into our debugger again. So, inputs, typo, list 1, and list 2. Now, if list2.tally gives us the number, a mapping of each number to the number of times it appears in the list. Like I said, Ruby's enumerable has really useful methods on it. So we can call this counts, and that's just list2.tally, and our solution should be list1 dot, we can even call sum directly, and it'll be n times list. Oh, this might blow up if we're missing elements from their numbers that don't appear. Right, and that's cool because you can Ruby hash set default value. I think you can set the default value of a hash after you've created it. Not after I've created it. Pretty sure that's a thing. Yes, there's a really good talk from this year's RubyConf from Nadia Onayu about the gotchas with setting default values on Ruby hashes. I think we'll be fine. It only matters. You only really hit nil can't be coerced into an integer. Why is there a nil value? Oh, it's sorry. This error is telling me that n is nil here. Why is n nil? I'm iterating over list 1, which doesn't. It's like 1,000 values. I don't see any null values in here. Okay, well. Let's just catch the exception and run our debugger in there. Oh, it doesn't like this. Okay. Because why doesn't, okay, so it's not that, it's, my default is not, come on chat, put the wrong variable in there. There we go. There's a value. My dog is barking because she rightly feels that it is 52 minutes past when we normally feed her. But it's okay because we have the solution. So that was not the most difficult. We leaned heavily though on this fact that Ruby's arrays support a transpose method, and we have this tally method, which both make this solution pretty straightforward for us. I want to do some more fun, weird programming on future days, but this was just one to get warmed up. So pretty happy that we landed on something pretty easy here. Also say, chat, if I ever go too quickly or anything, and you have questions about anything I'm doing, please stop me. I'm happy to explain anything I'm doing in more detail. But I'm going to leave it there. Go feed my dog and play some video games. But thanks for coming out and joining the stream.